Okay, now we have a plane flying horizontally 4,000 feet above the ground. Since we're talking about later in miles per hour, we can notice that this 4,000 feet is just 0.75 repeating miles. Okay, at a certain instant, the angle of elevation, which is this theta, is pi over 6, and it's decreasing, and the speed of the aircraft is 300 miles per hour. So we want to know how fast is theta decreasing at this instant. So notice that since we're given something about how fast the plane is moving, that's talking about this length here. So let's call this x. And so 300 miles per hour is telling us that dx dt is 300. Okay, so we need to use the ratio that uses both the opposite and the adjacent side. So that's the tangent of theta equals our 0.75 repeating over x, which we could rewrite this as 0.75 repeating x to the negative 1. So now when we take the derivative both sides with respect to t, derivative tangent is secant squared theta times d theta dt. And over here we leave our coefficient alone, pull down the negative, so we get negative x to the negative 2, and again for chain rule purposes we will multiply by dx dt. So now we have to figure out all of our known conditions. So we are given that theta is pi over 6. So to evaluate secant squared, I'm going to just do 1 over cosine squared of pi over 6. That's supposed to be a 6. I don't know what d theta dt is. I'll go back to that. Then I have my negative 0.75 repeating. Dx dt I know, so that's my 300 miles per hour. But note that it seems like we're not given enough information to find x. However, we know that at this instant, this is when theta is pi over 6. So we know that tangent of pi over 6 is 0.75 repeating over x. So we can solve for x using just a little bit of algebra here. And so x is approximately 1.312. Okay, substituting all these values in, this one I'm going to get 4/3 times d theta dt. And over here, this all simplifies to negative 132. So when I multiply both sides by 3/4, I get d theta dt is equal to negative 99. And this is, the units are going to be in radians per hour. Now I know it's in hours because this was in terms of miles per hour. Now this seems like a very large negative number, but of course since we're talking about how far the angle is going to go in a full hour, it's not surprising that it's going to be able to rotate negative 99 radians in that time. So there we go.